in the last class, we had discussed about alkenes, and we had decided that alkenes undergo electrophilic addition reactions. Electrophiles are electron deficient centers. Alkenes, alkenes have double bonds present between them. Double bonds have a large quantity of electrons amongst themselves. So therefore, they will attract electrophiles, right? Electrophilic addition reactions are basically an electrophile being added, followed by a nucleophile, right? This is a chart that I had made, right? If you are to notice, let's have, I am taking ethene. Ethene, when mixed with hydrogen in the presence of nickel catalyst, it produces ethane. You need to understand and you need to go through each and every reaction. You need to learn all of these reactions because they do ask you about all of this. Since hydrogen is being added, it is called hydrogenation. If I'm adding HCl at room temperature and pressure, it is called hydrohalogenation, and that produces chloroethane. If I'm adding Cl2 at RTP, it is used to remove lead from leaded petrol, right? Such that chlorine gets added to both the carbon atoms. I'm adding chlorine aqueous. This will produce chloroethanol. Basically, chlorine gets attached to one, and the aqueous part has water content. From water, you have the OH part. अगर मैं chlorine aqueous add कर रहा हूँ, तो chlorine gets attached to one of the carbon atoms. Sorry, we are here. Chlorine aqueous में chlorine is mixed with water. So chlorine gets attached to one of the carbon atoms and OH gets attached to the other carbon atoms, right? If I were to talk about Cl2 aqueous in the presence of concentrated NaNO3, तो अब एक कार्बन पे Cl लगेगा, दूसरे पे NO2 लगेगा. सबके reaction mechanisms बहुत important है जो हम करेंगे, ठीक है? If I am adding water at 300 degrees Celsius, 60 to 70 atm pressure, and H3PO catalyst is used, I end up producing ethanol. Alkenes undergo addition polymerization. Ziegler-Natta catalyst is used in this respect, right? Moving forward, if I were to add oxygen to an alkene, it will produce carbon dioxide and water because these are the combustion products. Please understand that KMnO4 is a strong oxidizing agent, right? And KMnO4 has the tendency to oxidize ethene into diol. Diol is basically a compound having two OH groups present. Moving forward, let's say I have the mechanism with chlorine gas. Chlorine is somewhat like Cl2. It is a non-polar compound. If I'm bringing alkene closer to it, I mentioned that double bond is electron rich and therefore will attract to the electron deficient chlorine, right? Please understand that CCl4 is a solvent in here, right? CCl4 is used to induce polarity between the chlorine molecules because chlorine is non-polar, meaning to say it has no poles present. So when the double bond attacks one of the chlorine atoms, right, the positive gets bonded and thereby breaks the double bond. If you check, and as soon as the double bond breaks, right, this carbon has all of its four bonds satisfied, whereas this one has one bond missing, and therefore will attract the chlorine having the negative charge, and therefore you get 1,2 dichloroethane. Since this is a two-step reaction, we have a two-hump graph. The initial part, the first bond breaking part, would have a greater energy of activation because you need to actually provide heat in here. However, for the second part, where the intermediate is this negative part and this part reacting. When the intermediates come in together, they will simply just react and nothing else. Mechanism with aqueous chlorine, right? So in aqueous chlorine, you need to understand again your double bond. The step one stays same. The double bond will attack the diatomic chlorine, right? The double bond breaks and one of the chlorine gets added. Now you need to understand that aqueous chlorine will have two nucleophiles present. One is the Cl negative and there is also an H2O. H2O is a stronger nucleophile because of the presence of a lone pair on the water molecule, which will attack this positive part. Please understand, whenever you are drawing mechanisms, arrows will always come out from the negative part of the molecule towards the positive part, right? So it will somewhat form this bond, right? The water was initially like this, but when the lone pair attacked the CH2 molecule, it will form another third bond. Oxygen being in group 6 cannot have three bonds, so it will have to let go one of its bonds. It will remove a hydrogen instead of getting itself removed from here because it has just made this bond and is not ready to go back to its initial state. So removing a hydrogen is more feasible, right? So we'll take off this bond, or it will take off this electron, thereby making hydrogen a positive nuclear, which gets attacked by the chlorine, and therefore we have chloroethanol, right, plus HCl. Please understand that in the container there are a large number of molecules. So if chloroethanol is in major quantity, there is a minor quantity as well. There is a chance that this is made as well, simply by the fact that chlorine will attack the positive molecule. Mechanism of chlorine aqueous in the presence of concentrated NaNO3. Again, step one will stay the same. The alkene molecule attacks the chlorine molecule. However, it is the step two, which is because NaNO3 is concentrated, right? It will attack the remaining molecule because of its high concentration. In this case, there are other possibilities as well, again because of the fact that there are a large number of molecules present and not just one or two. This will be in major quantities, whereas the other possibilities will be in minor amounts. Comes in the reaction with steam. You need to understand that steam will react in the presence of H3PO4 catalyst. The catalyst reacts first, right? H3PO4 will be attacked. Now H3PO4 has a oxygen which is electronegative, so it takes the electron density towards itself. Right? When it is doing so, right, it will be attacked by the ethene molecule, which breaks its double bond and will attach the hydrogen to it, right? Moving forward, steam has water molecules present. They will detect the positive ion here and thereby form a bond here. Oxygen cannot make 3 bonds and therefore has to remove 1 bond, right? So it will remove the hydrogen from itself. The hydrogen, once removed, will be attacked by this oxygen here, right? And we receive our H3PO4 as it is with ethanol from ethene. You need to understand that H3PO4 here is acting as a catalyst because it did not take part in the reaction. It is regenerated at the end as it is.
So it took.
Manganate plays a very important role. In cold conditions, the double bonded carbon atom is converted into a diol. Each carbon which was involved in the double bonding will now end up with an OH. If you check,
So is it because the double bond is going to break and then
no, it is because KMnO4 is a very strong oxidizing reagent, right?
Okay.
Oxidation is a loss of hydrogen,
All right?
Or a gain of oxygen. Having OH means your hydrogen content is reduced. Hydrogen content is reduced and your oxygen content is increased. Moving forward, in cold conditions, KMnO4 converts into a diol. In hot conditions, KMnO4 has a different role. Now let's say this is a RCH molecule. It will take this entire part, one side of the double bond, which is RCH. R can be any alkyl chain, CH3, CH2, 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 and so on. It will convert it into an aldehyde. This being the functional group for an aldehyde. And the remaining CH2 carbon will be oxidized to carbon dioxide. Water H2 will be oxidized to H2O. समझ आती है ये बात?
जो R group है, what if it's also containing another double bond?
अगर R group है, what if it's containing another double bond? You mean somewhat like this? एक ही मॉलिक्यूल में दो डबल बॉन्ड्स हैं.
Exactly. Yeah, diol. No,
दोनों.
I mean, no, diol.
It's not diol. No, that's not a diol. वो दोनों को कर देगा. For example, ये देख लो. ये लो. ये वाला में मल्टीपल डबल बॉन्ड्स हैं.
Okay.
तुम कार्बन्स को डिटेक्ट करो. ये CH3 है. ये वाले कार्बन को देखो, एक बॉन्ड, दो बॉन्ड, तीन बॉन्ड, चार बॉन्ड, इसके पास कोई हाइड्रोजन नहीं है, तो ये कीटोन में कन्वर्ट होगा. कीटोन इज बेसिकली दिस पार्ट.
All right, sir.
This carbon also has one bond, two bond, three bond, four bond. It gets converted into a ketone. This gets converted into a ketone. This is the ketone functional group, C double bond O between two carbons. Next is Markovnikov's rule. It's that in an unsymmetrical alkene, the positive part of the unsymmetric reagent goes to that double bonded carbon atom where we will have more hydrogen. Basically, this is a symmetrical alkene. Right? This is an unsymmetrical. Left hand side is not equal to right hand side, right? So it is an unsymmetrical alkene. This is an unsymmetrical reagent. This is a symmetrical reagent. Markovnikov's rule is for unsymmetrical alkenes and unsymmetrical reagents. For example, I have CH3CH2, right? The rule says in an unsymmetrical alkene, the positive part of the unsymmetrical reagent. Now, this is water. This is the negative part, more electronegative part. This is the positive part. So the positive part of the unsymmetrical reagent will go to that double bonded carbon atom where we have more hydrogen, meaning to say hydrogen should be added to this carbon, and thereby this produces a major product. In short, Markovnikov's rule says a carbon which is rich in hydrogen gets richer. Right? Since this is a major product, there is a possibility that the hydrogen could have been added to the other part and thereby form certain minor products.